Welcome back. We're taking a look at section 11.1, the circumference and arc length. Now that you got a little taste of a circle in chapter 10, in chapter 11, we're going to look at a little more details as far as the outside and also the inside later on in this chapter. So to start off with, well, what are parts of the outside? Well, that is the circumference. And what exactly is the circumference? That is the distance around the circle or outside of a circle. Now, it's easy to find the whole thing, right? The distance around the circle. Well, we got an equation right here where c being circumference is 2 times pi times the radius. But now, I don't care about the whole entire circle anymore. I might want to find the arc length of the circle, right? Or a specific arc. And that, what exactly is that? That's the distance between 2 points. So if I have like point 1 right here on this circle and I go ahead and draw a second point, what I want to figure out is what is the arc length, and that would be what is the distance between those 2 points? Or how much of the circle do you see right there? Or what is the distance between those parts, right? And it can't be 2 pi r because remember, that is the whole entire circle itself. We got this term radian. We'll talk about that a little bit more in a bit. But on your calculator, remember, you have two modes. You've got degrees and you've got radians. And it's kind of like thinking about degrees Fahrenheit, degrees, what is it? We have degrees Fahrenheit, we have degrees Celsius. Right, you've got two different numbers, but they mean exactly the same thing. And that's kind of how radians and degrees work. Degrees, you have an actual number that makes a little bit more sense to you because you're used to numbers between 0 and 360. But when we talk about radians, it's like this transformation, it's like a conversion. And like 2 pi ends up equaling the same thing as 360. Or pi over 2 is the same thing as like 90 degrees. Or pi itself is 180. Right? Those are all like little conversions, and they mean the same thing, except one is in radians, the other is in degrees. It's like saying, hey, we have degrees Fahrenheit, we have degrees Celsius. In America, we're used to talking about degrees Fahrenheit. So if I say 100 degrees, you know it's a hot. But if I said something is like, like 40 degrees Celsius, you don't know whether that's hot or cold, right? And so that's kind of how you might think of radians and degrees for now, until we get a little more, until we become an expert at it. So once again, right here, we talk about circumference of a circle. There are two equations, right? And one of the equations is circumference is equal to pi times d, which is pi times the diameter. Remember, that is the whole length from one side of the circle to the other. I'll go ahead and highlight that right here in red in our circle. And then we have 2 pi r. And so it's going to be 2 times pi times the radius. Now, in good practice now, do not use 3.14 in your calculator. You're going to use that pi button, especially because you have access to a scientific calculator or the Big Ideas calculator. So make sure you use that. Now, why are they the same? Because remember, if you take 2 times the radius, that's going to equal the length of the diameter. Take a look at the diagram. If I were to draw right here, remember, from the center to the outer part of the circle, right here at the bottom, and I'm using purple now, that represents r. From diameter, or the center to the other side of the circle, that's r right there. So we have 2 radii, 2 times the radius equals your diameter. Let's go ahead and move on. Let's figure out arc length, okay? And so the thing you have to memorize right here and know how to use is this ratio or this proportion, okay? You must make sure you memorize this. So I'll go ahead and include that right there. The arc length of arc AB, if you divide that by 2 pi r, that is equal to the measure of arc AB over 360. One thing to kind of keep note as you try to memorize this is that on the left side right here, we talk about length. Over here on the right side, we have degrees or angles. So that might be one thing to kind of keep an eye on to help you remember, all right, what do I put on each side of this equation? Now they do simplify things down right here to where arc length of AB is equal to the measure of arc AB over 360 times 2 pi r. Do you have to memorize that? Not really, because you can get to this point right here by cross multiplying the top and getting whatever variable you are trying to find by itself. So I would worry about more the top equation right here more than the bottom one, because we can always get to the bottom equation. But if you need to figure out the radius, or you need to figure out something else in this equation, then you better know the top one, okay? Because you might need to figure out the measure of arc AB. You might need to find the radius, or you might need to find the arc length, okay? So on the left side, we talk about length. How long is the circle or the circumference of it? And then on the right side, we use angles. Before we get to working on some problems right here, let's take a look at this next piece. Converting between degrees and radians. So remember, I talked to you earlier, I said, hey, if you think about temperature, Fahrenheit, Celsius, and we've got like, they're mean the two same things, it's just there's a conversion from one to the other. To go from degrees to radians, what you will do is take whatever the degree is and multiply it by 2 pi radians over 360. Or you can multiply it by pi over 180. Why are they the same? Good question. Even though I asked it. I'm giving you the answer. Well, why do you think it is the same? Right? Because if you were to simplify this right here, this 2 and 360, that becomes 1 over 180. That's why these two happen to be the same. And if you want to take it from degrees to radians, hey, multiply by pi over 180, simplify it down, and you'll get your answer in radians. If something happens to be in radians and you are trying to multiply or turn it into degrees, then you're going to go ahead and multiply it by 360 over 2 pi or 180 over pi radians, and then you will get your measurement from radians to degrees. Memorize it. There you go. As we move on, we go ahead, take a look at some of these word questions. All right, they give you some information here, and your goal is to try and find what's missing. One key thing in big ideas and in this section and chapter, okay, round to the nearest hundredth. Okay, so round to the nearest hundredth. So let's take a look at number 1. It says the diameter of a circle with a circumference of 10. That's what I'm trying to find. Well, let's use our equation. Always start off with the equation. We have circumference is equal to 2 times the diameter, right? Or, sorry, circumference is equal to diameter times pi. Or we have circumference is equal to 2 pi r. I like pi times d, or d times pi. Let's go ahead and put it like this, since that's what we have in the book. Because, hey, we're trying to find the diameter here. So what do? Since they gave us a circumference of 10 inches, let's go ahead and plug 10 in for circumference, and then we have ourselves pi times d. So I need to get the diameter by itself. We'll divide both sides by pi. And if I ask for an exact answer, your diameter is 10 over pi. But I do know that big ideas ask for a rounded answer. So 10 divided by pi ends up being approximately 3.18. And let's not forget the unit of measure, 3.18 inches. Okay, let's go ahead and go to number 2. On this one right here, out of the 2 equations for circumference, they're saying, all right, we have a radius. I want to go ahead and use circumference is equal to 2 pi r. We're finding the circumference. This time they give us the radius. So we go ahead and plug that in. We got 2 pi times 3. Make sure in your homework you use the equations. If I ask for the exact answer, this would be 6 pi. The rounded answer ends up being 18.85. There will be many times where I'm going to ask you for the exact answer only. So make sure you can simplify these expressions. Next up, number 3, find the radius of a circle with a circumference of 8 feet. Okay, so let's go ahead. We've got circumference is equal to 2 pi r. We have right here, circumference is 8 feet. So I'm going to go ahead and plug in 8 right there for C. And then we got 2 pi times r. In order for me to get r by itself, I'm going to have to divide both sides by 2 pi. Okay, and so an exact answer, this would be 4 over pi in simplest form. If we go ahead and plug that into your calculator, 4 divided by 3.14, or obviously the pi button, this ends up becoming approximately 1.27. And we're dealing with feet. And so there you go. Next up on number 4, find the circumference of a circle with a diameter of 2.4 feet or meters. So we have right here circumference is equal to pi times d. We got ourselves pi times the diameter is 2.4. So I'll go ahead and plug that in right there. Using your calculator. Well, exact answer would be 2.4 pi. And then using your calculator, this becomes approximately 7.54 meters. All right. This is where the hard stuff begins right here at number 5. Let's figure out the arc length of AC. So we got to go back and let's think about our equation. On the left side, okay, we have, it's like arc length over, and remember, since we're talking about length, let's think about the distance around the circle, which is going to be circumference. So let's go ahead and use 2 pi r. Okay, and if you haven't realized that denominator is the circumference of a circle, 2 pi r. That's equal to, on the right side, we are dealing with angles, the measure of arc length. Okay, the measure of arc over, and then remember, a circle all the way around is 360 degrees. So from here, we can go ahead, hopefully now plug some things in to help us figure out finding the arc length. One thing right here that I see standing out in the diagram is 3 inches. That is your radius. So r is equal to 3. So in our equation right here, I've got 2 pi times 3. That's equal to the measure of the arc. Now, what is the measure of the arc? They give me this 70 right here. Well, what good is 70 when I need to figure out the measure of the arc right here, which is AC? Remember, if 70 is the central angle, then that is equal to the measurement of that arc. So that arc measure is also 70 degrees. So right here, we're going to go ahead and put 70 over 360. The arc length is unknown, and I'm going to go ahead and put an x right there. So what do? Solve for x. That's all you're going to have to do. Cross multiply. Okay? So what I'm going to do is go ahead with cross multiply. X times 360. We have 360x. And that's equal to 70 times 6 pi. Let's simplify things out. Let's get x by itself. We divide both sides by 360. Okay. If we want the exact answer, let's go ahead and do a little bit of work right here. 70 times 6, that's 420. So this will become 420 pi over 360. If we were to get that as an exact answer, hey, the zeros can cancel. Looks like top and bottom, we go ahead, we have 6. So it becomes 7 pi over 6. And then there you go, you'd have an exact answer. But I do believe, and big ideas for this question, they do not ask for an exact answer. So if we take 7 pi, right here, divide that by 6, we get ourselves 6.665. And what does that mean? That rounds to 3.67. And then we got ourselves inches. We have now found the exact arc length of A to C. Let's take a look at the last part right here. Problem 6 and 7. We're going to take 60 and we're going to convert to radians. Remember, if we convert to radians, we're going to have to multiply it by pi over 180. And think about this. If you took chemistry, you may have heard this before, where you're trying to cancel out things that you're trying to convert to. If 60 is in degrees, look, we have 80 down here in degrees as well. And that will allow things to kind of cancel off, and then you're left with pi. And that pi happens to be, if pi is in your answer, you're going to have it in radians right here. So let's go ahead. We got ourselves 60 pi over 180. If we go ahead and multiply it across, and then 60 over 180, that ends up being pi over 3. And this right here is in radians. Pretty simple. So let's go to number 7. Okay, we have an answer or a measurement in radians. And if I want to go ahead and convert this to degrees, I'm going to have pi on the bottom and 180 on top. Because look what happens right here. Pi cancels out when we cross multiply. So then, without pi, we're in radian mode right here, or sorry, degree mode. So let's go ahead. We can multiply straight across. We can do some other things to help us simplify. I could do a little more reducing right there. That becomes 1, and then this becomes 30. And guess what? Without a calculator, I went ahead, 5 times 30, that right there is 150 degrees. We now converted from radians to degrees. And there you go, section 11.1. The hardest part right here happens to be problem number 5. You've got to know how to do that, okay? Because when we start taking a look at the next section, it's going to be very similar to what you just did right there. Make sure you know that equation. Otherwise, you can't solve these questions. All right? Thank you very much for watching. If I helped you out, guys, help me out. Like the video, subscribe to the page. Hey, if you even have a question or want to say something, put it in the comments. All right, have yourselves a good day.